Well, hello, everybody. Good morning, good afternoon, good evening, good night, I suppose, to everyone, wherever you may be, somewhere across our lovely world. Thanks for joining us live here today for the one and only Serverless Office Hours. We're streaming on the AWS Twitch channel, so if you're joining us via Twitch, hello, hello. And also, if you prefer YouTube, great for you as well on the AWS Events channel. My name is Julian. I'm a developer advocate and been doing sort of serverless at AWS for a number of years. And this week we are talking Lambda and we're talking performance, and two of my favorite gurus to come and explore this with us, Matt Diamond and Paras Jain. Welcome back to Serverless Office Hours. Paras, first up, for people who don't know the awesome Paras, how on earth have you managed to be talking about Lambda and performance and be at AWS today?
Yeah, thanks, Julian. Nice to talk to you and Matt. Nice to have you. My name is Paras Jain. I am a senior solutions architect based out of London, Virginia, and been in AWS for more than 6 years now. And to answer Julian's question, I am part of AWS Serverless TFC, which is Technical Field Community. And as part of the Serverless TFC, the question of Lambda performance comes every once in a while, and customers ask how to make sure that we make the most out of Lambda and make it most performant. And hence, we are going to talk about it, and we have some tidbits to share with you.
Awesome. Yeah, looking forward to that. I love sort of Lambda story of 10 years old. And some of the best practices evolve over the time, and some of the things that people think Lambda can't do, it can anymore. So yeah, everything has changed. But Matt is also one of the most awesome serverless people who I've worked with closely over the years. Matt, how on earth did you land up doing serverless at AWS?
So, hi, Matt Diamond. I'm a solutions architect. I'm based in Charlotte, North Carolina. I've been with AWS about 6.5 years, and I really like the serverless concept. I've always enjoyed the fact that you only pay for what you use, and to me, that's always from a recovering developer, so to speak. It's always been kind of an exciting thing for us. So I love talking about it.
Cool, excellent. And we do have our global serverless community all representing wherever you are in the world. So please tell us where you are from. It's amazing to pop around the world and see Edits, who's a regular watcher. Thanks, Edits, for joining us again. Hey, everyone. We've also got Daniel Habib joining us from Sao Paulo in Brazil. Hello from Sao Paulo. Edits is from LA. So yeah, please tell us where you are. And particularly this week, this is actually about you who are watching. It's all about the Lambda best practices and finding out what you want to use things for, answering your questions, answering your questions, all these kind of things. That's the reason you join us live. But for those of you who are watching in another time zone, and I appreciate you don't necessarily watch us live, hopefully this is all useful as you send us the questions in your comments and we'll bring them up on screen. So who should I jump off to first? We are starting about Lambda performance, tuning, best practices, and guidance. Who wants to take us away?
Yeah, so I think I will. So that's a really long title for us to ask about how do you get the best out of a Lambda function. And typically, we talk about this in 3 parts. We're going to talk about this in terms of, how do you performance tune and optimize a Lambda. And then we're going to talk a little bit about how would you deconstruct a microservice and actually make it, again, make best for performance and best for tuned. And then we're going to talk to you about some developer tooling as well. So let's get right into it. So typically, we have this pattern, the Lambda-lith, right? Where API gateway is calling a Lambda, and that Lambda does X, Y, or Z. And so this Lambda is all in one. And this is a very typical pattern. And so one of the questions we always, kind of start this conversation off with was, how do you make this better? Like if you were to think through some of the ways to improve this Lambda, what would that look like? Like what would be some things? My favorite thing is always to talk about the giant memory dial, or CPU. Like those are ways we can improve Lambda performance. I'd just love to hear, maybe there's some in the chat. We could put some other ways we could improve this Lambda and just kind of think through that for a moment.
Yeah, so please put your questions in the comments either on Twitch or YouTube, and even start at the beginning. Like, even let us know, is there even anything wrong with this or even anything right with this? Because that's one of the kind of things with Lambda. There's nuances and trade-offs with everything. I think Matt and Paras are going to talk today about. There are some obvious things that you should really do. But there's, and in fact, I will go on one of my tangents while some questions come in as well. Because even the term Lambda-lith, because I know some people, talk about fat Lambda and sort of Lambda lift. And then I've been chatting to developers, over 1 year now. I clearly remember one particular conversation where somebody said, well, I used to have a big honking EC2 instance and a number of them with an auto-scaling group. And in fact, we then moved to containers, but I had these big containers and do all of this kind of thing. And then I've moved everything to microservices. I've moved everything to Lambda. And my Lambda functions do a whole bunch of things. You're telling me I've got a Lambda lift. I had a monolith over there. I've done a huge amount of work. I'm already serverless. And I'm already with Lambda. And you're telling me I'm doing things wrong. So,
that's right.
What do you say to people who are thinking they've already done something wrong when maybe they have a Lambda function with a few roots in it?
That's right. So a lot of folks will start developing with Lambda, and then they'll experience the dreaded cold start, and they're trying to figure out, like, how do we make that better? Like, what are ways to improve that? From a performance and a tuning way. And so, some of the ways that we, typically talk about that would be, memory, CPU, the size of your code, the runtime. Like, there's just a number of different ways to make that happen. Paras, I'd love for you to maybe, talk about your first favorite one and just kind of build that out just a little bit. Talk to us a little bit about, some of your favorite ways to improve a Lambda.
Definitely. The way we structure our first discussion on Lambda performance is to talk about a Lambda lifecycle. There cannot be a Lambda performance discussion without a Lambda lifecycle discussion. So if you bring up the slide, yes. So when a Lambda is invoked, typically when the first time it gets invoked, these are the lifecycle phases or stages Lambda goes through. The Lambda service will first download your code from zip or an internal S3 bucket or a container image. Then it will spin up a new execution environment, which is a Firecracker micro VM. Then it runs your code, your init code. That's everything outside your handler, your imports, database connection, SDK clients, etc. And it finally executes the handler. The first three phases are the cold start, which is something experienced when the first invocation is made. And the last one is the actual execution handler where your logic resides. Now, why we talk about life cycle when we talk about performance is because from your customer's experience point of view, every single phase is important because that's what they see from execution to the result. So that's why we have to optimize each and every phase when we optimize the Lambda performance. How do we do that? So let's talk by phase. So in download code, as Julian said, there's no right or wrong answer. Everything, if it works, then it works. There are trade-offs. But in Lambda world, we try to avoid Lambda lead because it comes with some cons and disadvantages, and Matt is going to talk about it. So avoid Lambda lead if you have to optimize the download code phase of your Lambda function. Then we talk about optimizing the dependencies. For example, import only what you absolutely need. When you start developing a Lambda function, typically you start experimenting and start adding a lot more things, and you fine-tune it, you remove unnecessary functions and logic, but sometimes those dependencies and imports remain. So you have to remove unnecessary imports or libraries you don't need anymore. And if you are including a library, for example, if you are talking to a DynamoDB database, then in your SDK, don't include anything other than DynamoDB SDK part. Don't just include the core libraries you need for whatever you are doing. And now I talked about the dependency and library, and this is where the choice of the library itself is very important. And Matt, you have a very good story to tell about the choice of the library, right?
Totally. So our friend Luca and I, a couple of years ago, we did a very similar talk, and we actually wrote a white paper that talked about reducing your cold starts. And what we discovered was that if you were to choose the Sequelize library, it was about 1.6 megs, versus if you used the Sequelize.js library, it was around, like 400K. And so just the difference in the size of the library made a significant improvement. So not have to download all that code every time you wanted to invoke. So just even the size, the library you choose and the size of it is going to have such a dramatic impact on your performance.
Yeah, excellent. Yeah, and Once you choose the libraries, the right kind of libraries, the importing is just enough thing. You can further optimize the size of your payload or size of your code by using techniques like minimization or minification. For example, these minification libraries can strip out everything from your dependent packages that runtime doesn't need to the comments and white space, long variable names, unused codes, all that is gone using tools like ESBuild or Webpack for Node.js. And then it can take your function, any dependencies, and shake out unnecessary stuff from your code. So that will compact your code really good. And we have seen customers going from multi-megabyte package to a few hundred kilobyte by using such techniques and technologies. So that will really uh, optimize your Lambda code just to the minimum you need, and that is going to go a long way. Matt, anything you want to add here before I move on to the next section?
No, I think that's good. Only thing I did want to mention is I did make a mistake. I was saying we'd use SQLize and then Postgres.js was the updated library. So my apologies for that.
But
Go ahead.
the whole point of this is that the smaller your
Yeah.
package size, the quicker it's going to download from S3. Is that the?
Yes, exactly. And really, scrutinizing, every dependency, making certain that you're really thinking through, do I need this? And have you found the most recent version of it? And is there a better version of it? Really thinking through that, we've found to improve performance.
Okay. Is there any thoughts or considerations people should use if they're using container images? Because I know container images also do cache kind of things. And container images can also be up to 10 gig, while an unzip Lambda function could be 250 meg. So there may be situations where you do need to go to container image, either from the image size you need or just because you like container tooling. So does that change anything?
It can. I think that to your point, it's going to, whether or not you use containers or you're going to be using the traditional zip is really going to be decided based on how your workflow and what are you doing today from a development standpoint. It can, because when you start to use containers, there can be some additional performance overhead. It doesn't necessarily remove the cold start part of it or improve the performance in that regard. It lets you really have a continuous workflow, and it also lets you have a larger image size, which is really nice for some of our customers.
Okay, and yeah, the one thing I was also thinking, just to add to that, if you are using a container image, it's obviously made up of different layers, and AWS is going to cache as much as possible ahead of time. And there's in fact, it's an awesome technological thing behind the scenes, the way it actually caches it. It's completely secure. No other customer can see, or even we can't as AWS see what's in those cache chunks, but we can actually efficiently cache them and do all this kind of thing. Like there's all the technology behind it is actually awesome. But it means that actually constructing your container layers in a particular way, as you would do with any container image format, by having the base layers be changing as least often, and then the layers further down in your stack are the ones that are more changing. So, for example, if you had your function code as the second layer, and then you added the SDK, and then you added, I don't know, whatever NumPy libraries, or I don't know, some agent kind of framework that's huge, it means every time the diff of that whole container image is going to be very different to any other workload. While if we add the SDK first and then maybe some other kind of libraries and do a sort of ordering of things that change the least to things that change the most, means it's more likely, and you don't have control over this, and it's great you don't have control over this because AWS just sorts it out for you, but it's more likely that those chunks are going to be in the cache, and so things are just going to be faster than you would expect. And I'm doing a bit of hand wavy vagueness here because it is a cache and you don't actually know, but it's a little a performance tweak you can do to actually hopefully get the cache more, I don't want to say warmed up, but more likely that your stuff is in the cache.
Sure.
I like the use of the term more likely, because a lot of the things we mention in this talk is, kind of, you try it out, your mileage may vary, you may or may not get a performance improvement, but a lot of things are very deterministic. But we'll talk about some of the things which are, you have to try it out and see how it works for your Lambda function.
Yeah, and I think also the meta thing of this is also good software best practices. Less code, less stuff to maintain, less stuff to look after, minifying things, container image layer. This is stuff that's not even specifically particular to Lambda, but anywhere you want, anywhere you're running code, you want it to be efficient. And so take those best practices and just make sure you're applying them with Lambda. Gives you bang for your buck.
Definitely. Let's talk about the execution environment, the second phase you see on the diagram. Now you would think that this is not something I control as a developer. Yes, you are right. Lambda service controls how it goes and fetches up the new execution environment for you and spins up it for you. But what you control is the memory, the architecture, and how the environment starts. And Julian touched upon it a little bit. Let's talk about CPU and memory. So as you know, and some of you may know, that Lambda allocates CPU proportionate to the memory you allocate to it. So more memory you allocate, better performance you will get, because more CPU you will get. But as you keep increasing the memory, you start getting diminishing returns for your CPU. And we'll talk about this whole art and science behind what is the right number, what's the right memory. We'll talk about it in a section on tooling, on power tuning. So that's we'll cover later. But that is very important, very, very important part of your performance tuning, to choose the right memory. Architecture. So whether you pick x86 or Graviton, Graviton in our customer anecdotes and examples, we have seen that you get up to 34 to 40% of a better price performance when you choose Graviton-based instances. Your mileage may vary. And again, we'll talk about power tuning, and that's where you can use techniques and tools like power tuning to compare your particular Lambda performance in x86 and Graviton. Now, the third part, how the environment starts. This is where you can make some influence or some decisions which can influence how it gets done. Here, I'm going to talk about two techniques: provision concurrencies and snap start. So provision concurrency is a functionality using which you go to Lambda and say that I need 100 provision, compute resources. So you publish a Lambda function, enable provision concurrency, and give a number, say 100, and Lambda service will download your code to 100 of those instances, initialize your code, and keep it warm for you. So next 100 invocation requests you get will go to the warm 100 concurrent, and these execution instances are going to be available to you warm, and it is going to give you performance boost if you have if you know that you are not going to go over 100. You are not going to get throttled if you go over 100, because then you will go through the usual life cycle of the cold start. So that is a very good technique. It costs it's the priced feature, so you have to pay for it, but for the latency sensitive application, this is very important. Now, the second technique or feature in the Lambda service available to us is snapstart. So snapstart was introduced for Java, where it was kind of a very tough problem to solve. Java was designed for running into servers, which does not have the problem of cold start. So with Java or any cold start system, with Python and .NET also, you use a snapstart to enable on a particular version. And the way it works is a little different than it works for provision concurrency. So when you enable snapstart, Java Lambda service is going to execute your code. It will initialize an environment, execute your init, download your code, execute the init, and then take the tiered cache of your memory and disk and keep it in the caching system. Now, as your invocation comes, instead of doing the download and executing the initialization again, it will just do the resume invoke, which is much faster. And again, this is also indeterministic. You may or may not get that much of a benefit depending on the kind of Lambda function you have. But again, this is a good feature to test it out and see if your particular Lambda function is going to benefit from snapstart. So these are the techniques you can use in the second phase of starting the execution environment. Anything I'm missing here, Matt?
No, I don't think there's anything you're missing. I think I did want to come back to the Graviton comment and just kind of bring up one other additional item. So a lot of folks ask, will Graviton be faster, or how do I know? And the best way is going to be to test. And all of these things, there's just a kind of an element of testing that you have to do. But specifically with Graviton, just testing your code with Graviton is going to be the best way to know whether or not you're going to get those performance improvements. But generally speaking, managing your memory and ensuring that you're not starving the Lambda for CPU and starving that your Lambda for memory is going to be key. And we're going to talk a bit about how do you know how that works when we get to tooling, because we have some great ways to be able to handle that.
Exactly.
Just from an overall architecture thing, if people don't know about provision concurrency and Snapstart, is there a rubric for understanding, or which one do I pick? Which one's better, which one's worse? Do they have trade-offs? Can I use both? If I'm thinking, well, this is cool, of course I've got to reduce my cold starts. How should I think about which one over the other?
So if you go for it.
No, go ahead.
If you have a predictable pattern, and if you have predictable scaling you need, and then you have strict latencies in terms of SLS, then you can use provision concurrencies, because there is no, the first three phases you see here on the diagram are gone in the provision concurrencies. There are some pros and cons. The pros is I described. You will not have the cold start. The cons is how to determine the right number, whether it's 100 or 1,000 or 10,000. You also need to worry about your account level. There's a concurrency limit which you can increase, but regardless, you don't know the right number. So if you have predictable pattern, and you know that you need certain number of concurrency, you can use provision concurrency. The good thing is you can use auto scaling with provision concurrency. That means you can use auto scaling groups, and then it will scale up. There are limits on how fast it scales. You can read the documentation on that, but that's where you would need provision concurrency. It's a price service. You pay money for it, but you will get predictable performance. Snapstart, especially for Java, works differently. It's a tiered cache. Tiered cache means we cache based on what we think is going to be needed the most, and we keep improving the cache. The cache is on multi-AZ and whatnot, but it's not very predictable. You may or may not get the benefit because you do the resume. It's not the warm instance available. You do the resume on a new instance, and that's how you get the performance. So it's not that predictable. Matt, anything I'm missing here? Anything?
No, I was going to say, we always get the question, like, what's the best runtime? Like, which runtime should I use, or what should I be looking at? And we always say it's going to be the one that's going to be that works for you and your team as you're developing. But on the flip side, things like JavaScript, TypeScript, and Python, they're just inherently going to be faster, just from that initial, from those first two boxes that we're talking about, versus things like Java or .NET. Now, Snapstart have significantly improved those, the performance on those, but you're going to want to pick not only the runtime that works for you, but if you have choices, those two, the JavaScript and Python, are typically a little bit faster. We're seeing a lot of folks get interested in Rust. We're seeing LLRT, or low latency runtimes. Yes, Daniel, 100% we should use Rust, and it's a good call out. And we're seeing a lot of folks do a lot of experimentation, and they're incredibly fast. And so if you haven't taken a look at LLRT, I would do so.
Julian, does that answer the question? Anything you want to add? You are the Lambda performance guru yourself.
No, not in front of this crowd. No, I think sort of if some people are thinking, should I change my runtime because I want extra performance? Maybe, but I also think this is what Snapstart and provision concurrency also give you, that you don't actually have to change your runtime to get performance. And there's also two different ways to think about it. Performance, of course, is really important, but what do you actually need? I mean, are you running a high scale, low latency API front end for a e-commerce site that's making gazillions of money a year, and each millisecond, microsecond actually makes a difference? Or are you running a Python function that is doing some finding cats in images or that kind of thing for an async thing for your kid's birthday party? Different use cases. How much time and effort are you going to spend in optimizing these kind of things? There's also a part of it which is the synchronous path and an asynchronous path. If you grabbing data from S3 and you're putting it into a data lake, and it's going to be read and updated once every 6 hours, once every 12 hours, I don't know, once every week, really having 100 millisecond cold starts, do you even care? Would anybody notice? No. So of course we want to chase performance, but it is different when you think of things in containers and things on EC2 instances, where you don't necessarily have that option to separate your kind of workloads, and your async and all your sync and everything is running on one box. Then you're going to run your tests and go, oh wow, that is super fast for my async processes. I need to recreate it in Lambda. Maybe you don't. If you want to use, I think the point is Lambda can be ridiculously fast. If you see the LLRT stuff and you see the Rust kind of stuff, I mean, you're talking, down to 1 or 2 milliseconds for a Lambda function to run. So behind the scenes, Lambda is ridiculously fast. But if you want to use Java and you want to use .NET, or you want to use, NumPy, a huge big Python or PyTorch kind of thing, you can also really get, minimal cold starts for that as well, without having to, oh no, I've got to now refactor this all in Rust. So bit of a long-winded way to say, but all of these other possibilities means you don't necessarily need to change what you're doing, which I think is a good thing.
Absolutely.
Yeah. And there's no tech talk involving architects without the mention of the word it depends, right? So it all depends on what your use cases are, what your particular Lambda function is doing. So, all good, Julian. Thanks for.
Cool, excellent. But I mean, just to bring some of the comments in, Gigablast here, thanks for your comments via Twitch. We use Lambda extensively atop a live voice stream via data via Amazon Connect, where this performance latency is critical. So this will help our refinement. Well, thanks for watching. So yeah, this is the kind of thing. If you're doing a live, bi-directional voice chat kind of thing, when things dropping out, that's latency sensitive. But maybe you're doing those voice chats and then you're doing a transcription job to be able to store it in Salesforce or that kind of thing, and that's after the fact. You don't need the performance. So again, Paras, as you say, it all depends. But at least we've got lots of tools in the toolbox to help with performance.
Yeah, excellent. Let's move on to the next phase, the third box in your screen right now. And this is where I will go back to what Julian mentioned. A lot of the things we talk about is not specific to Lambda. It's, I as an ex-developer, I was a developer in the past life before coming to AWS. And these are the things we used to do in the traditional programming paradigm. So how do you optimize the initialization phase? So if you can initialize anything you want to initialize, go for it. For example, if you are fetching any credentials from secrets manager or parameter store, instead of fetching it for each invocation, if you can help it, fetch it once and cache it so that the subsequent invocations will make use of those, those secrets and whatnot. Yeah, of course, you have to write for the logic if the secrets have expired or changed or things like that. But performance wise, it is going to be much more performant. You can use Lambda extensions for the same, or you can use the power tools. We are going to talk about power tools. In the power tools, you have a parameters utility, and that is going to help you with caching of your credentials. So cache your credentials where you can. Another topic we are going to talk in the second section where Matt is going to talk about connection pooling. Creating connections are a very performance intensive operation. And if you are going to create connections, do some stuff, instead of releasing the connection back, you can pull those connections so that the subsequent invocations can make use of it. So Matt is going to talk about it. The third concept is lazy initialization. And this is, again, another software engineering concept where in the init phase, you initialize variables which are very expensive to initialize, and you need it in the subsequent invocations. But the caveat is don't do it if you are using provision concurrencies, because with provision concurrency, you have to move everything to init, and you don't have to do the lazy loading and initialize only. You basically initialize as much as you can. Lazy initialization means, for suppose you have a variable and you are going to conditionally use it or not use it. For example, you are connecting to a database in some of your logical path and not connecting to it. There's no point in initializing. So do the lazy initialization for the things you don't need all the time. So just keep in mind that for the initialization point of view, that particular there's a timeout for that. It's 10 seconds. If you are using provision concurrency and snapshot, it's different, but any timeout is 10 seconds. So keep that in mind. Don't do too much initialization. So lazy initialization is another technique you need to use. The one last technique in the init phase is static data loading. That means if your function needs a reference data, a lookup table, an ML model, or a config file, something like that, you just load it and store it in the module level variable or in a temp, and so that it persists across the invocations. So those are some of the tips and tricks to optimize this third window, which is very short window, but it's important phase anyway. Anything, Matt or Julian, you want to add for initialization phase? Okay. Third and last phase. So choice of language, enough said about choice of language. Matt covered it. So choose the language which your team is most comfortable with. There are some languages which are better than others, but choose the language you are most comfortable with. LLRT, Matt touched upon it already. It's a low latency runtime. It is experimental JavaScript runtime built by AWS for Lambda, and it was built using QuickJS. Runtime version, this is very important in the handler part. What runtime you use, choice of language is to you, but try to use the latest runtime. So not only the latest runtime versions are most secure, they are much faster also. For example, customers who migrate from Node.js 16 to Node.js 20 have seen up to 20% or 15% of core star improvement without any code change. Just update the runtime. It's free, it's more secure, it's faster. And last but not least, Graviton we talked about. If Graviton improves your performance of the runtime or your handler code and the entire runtime. And Graviton is faster, it's cheaper, and always test it out if it works for you. Matt, do you want to talk about how to structure, go back to the Lambda Leaf diagram and talk about how to structure it better?
Well, I think that we're going to talk about that decomposition piece, right? And I think that was one of our findings was, typically when we're making these recommendations, we kind of started the talk out and said, hey, we've got this giant Lambda lift, it's really big, and it takes a while to load that up. And you've gone through the life cycle, so we can kind of understand a little bit better about why it would be important to break those apart. So we have another diagram, and this one is API gateway. We have three different Lambdas. One's doing a read, a write, and a read again. And it's going to these Dynamo DBs. So what we've done is we've deconstructed it. What's nice about this is that you only have to have the code in each of those Lambdas that is going to be needed to read or write. And so now, hopefully, you have a smaller code base and it's going to be a little bit faster. What's the other benefit to this? And everybody always asks, well, from a security perspective, now we're reducing the boundary, and you can have an IAM and a policy that's only doing read and only doing write. And so now you reduce your blast radius. So there's some inherent benefits, not only from a code perspective and from reducing the size of the Lambda, but we're also now able to scope down permissions. So the other kind of piece of this is you start to look at this and you start to say, hey, now I can start to actually have dedicated responses and dedicated queries. Well, that lends itself to more of a CQRS pattern. So now you can start to really use some different patterns and different frameworks to think about architecture. And what's interesting about this is, and we always ask the question, do we have to have one database? Does it all have to be Dynamo? Do I have to have a consistent? And no, the answer is you could actually break this up. And it could be RDS that's doing one specific thing. It could be Dynamo for another. And the benefit to this is now, you can keep the contract between API Gateway and the Lambda. But if the database changes or there's some other, you actually need to move it, you can. You have a little bit more freedom. But additionally, you can have the right tool, right database for the right job. From a performance standpoint, I have this cache aside pattern, and we bring this up specifically because when I mentioned earlier that Luca and I did some studies around how to reduce cold starts and what were some of the biggest benefits. The first one was changing out the dependency for the driver for going to RDS, specifically using a different driver. But the next piece of it was actually using cache or using Elasticache, and that improved performance significantly. And that was just because you didn't have to wait for the transition to go to the database. And by caching a lot of the data, it really helped to improve the performance of that Lambda. We always get asked the other question, which is, hey, cache is going to cost a little more money. It's going to be more expensive. And we fully acknowledge that. We always want to be able to balance cost, but we're talking about performance. And so we want to ensure that, if we're going to make all the recommendations to improve these things. Next up, when we start to talk about this decomposition piece, is we start to ask ourselves, are there ways, Julian had mentioned earlier, you'd mentioned, asynchronous and being able to, asynchronous versus synchronous. Well, a nice thing around Lambda is, specifically in the write pattern, you can start leverage things like SQS and queuing. And the benefit to that is now Lambda can just push all those writes to some type of queue. SQS is a great one for this. Now, we don't picture this here, but there's a Lambda in between SQS and Dynamo. And this is where you get one of the benefits of event source mapping, or ESM. And ESM is a great free feature that comes with Lambda. And what it does is it handles retries, and it handles how it pulls those messages off that queue. And by allowing Lambda to manage that, you're now getting an additional benefit where you're not having to think through that as you're starting to do your writes. And so this might not be the right pattern for you per se, but a lot of times customers leverage this type of pattern because they want to be able to very, very quickly push messages onto a queue and durably store them and handle them. So in the event that there's some type of problem downstream, they can reprocess them. I don't know, Julian, or is this? I mean, this is a typical pattern you've seen, I'm sure. And I don't know, any thoughts or questions you have there?
Well, my question would be, when do I need to consider this architecture? Because I can see the benefits of it. Of course, having a cache, having a decoupled write, you've got 3 different databases over here. But even if I've got three databases, should I set this up from the get-go, or at sort of what scale do I need to consider this as well? Because I suppose my bigger question is sort of over-optimizing, over-splitting, landing up with thousands of Lambda functions, doing tiny little things for low traffic, which means more cold starts, which means more complexity. But what are the sort of architectural trade-offs I should be thinking about? Or should I or when do I go into like, okay, I know I'm going to need caches, cache aside, all this kind of thing, which sounds great, but there's
I can take that a little bit. I can take that, and maybe Matt, you can add it. So yeah, premature optimization is the root of evil. Sometimes we go and to optimize. So optimize the code size and the graviton and all those things, but only when you go and actually your code is in production and running at scale, then you will know what are the pain points. Not to say that you don't have to think about those optimization upfront, but sometimes you over-optimize things which are not required. Even Lambda lead versus microservices, Usually, it's a good idea to have microservices, but maybe if it's working, if it's not that big, then maybe it's a good idea to have a Lambda lead. And that's where in the third section, we are going to talk about tooling a little bit, where instead of just guessing, you will have the access to some tools and events and metrics, which you can use to make informed decisions using X-Ray and CloudWatch and whatnot to say where are your pain points and where you need to optimize. Do you agree, Matt?
Absolutely. Absolutely.
And in fact, one thing I'm also going to just throw in here as a slight aside is a lot of people talk about splitting up Lambda functions for performance and for code size and all those kind of things and cold starts and everything, which I think is definitely important. But I think also there is a sort of organizational aspect to this of if you one developer and you coding one API with one database, you can definitely over-egg it by having too many Lambda functions. But the other side is also if you have a API gateway and you've got a Lambda function, you've got sort of 4 different teams writing code into that because this is, behind your API, and you've got a shopping service and a loyalty service and an inventory service, all these kind of things. And your teams are starting to trample over each other in terms of updating, and it gets hard with phase deployments and security scanning and blue-green kind of things. That's also another signal where you need to start thinking about splitting things over. So splitting things up, sorry. So it's not always performance. It's not always, there's some organizational boundaries. There's domain-driven design. There's, considerations of different tooling, different expertise, and all these kind of things. So there's the question, how big should my microservice be, is the biggest probably depend in all of the serverless. But
of course,
there are other additional things to think about more than just performance.
And we've seen customers go, to that extreme where they've gone to micro, and they've gone to so many small microservices that it's almost untenable. And so there's always a balance, right? And this is where great documentation and really thinking through your design up front, just like with Dynamo, really understanding your access patterns up front and being able to plan that up front is really going to improve your performance. And it's the same thing with microservices, understanding what your access patterns are going to be. How do you want to surface that data, and how are people going to access it? What is the contract going to look like? You really want to think through that and plan it well.
Yes, I suppose my don't over-optimize in splitting things up until you need to. Lambda and DynamoDB, specifically an API gateway, you can do a huge amount with API gateway, and even 1 or 2 Lambda functions, specifically if it's the same DynamoDB table. And you can go really far with these kind of things. And I've spoken to customers as well who are like, we're quite worried about the potential performance and overwhelming a database. And you say, what database do you have? Oh no, we've got Dynamis. I'm like, okay, great. And we would, how many transactions do you think you need to do? And like, we've had some busy times, and we have 300 requests a second or something. And so how long does it take to write to Dynamo? Oh, it's well under 100 milliseconds, often between 20 and 30. And you're like, you're not even blipping on anybody's radar on any kind of performance thing. So go and read some of the posts about AWS and Prime Day and how some of these serverless services are used, and your mind will boggle at the amount of scale. Now, that's not to minimize the work that they've done to do that, but there's a lot of throughput that these services can do.
Well, and over time, you asked, why would you want to use these patterns? What would that look like? I mean, the reality is that a lot of times applications, they grow over time. And if somebody says, hey, can we incorporate this feature or this service? And you're like, sure. And that's how things get to where we are, where it looks like this. And this is okay. It's healthy. It allows you to create some quick integrations.
And even the fact that you're using serverless services means I hope you're using the best service for the job, and it already gives you that extra agility, that extra way to, split a Lambda function, add another one, combine one together, in ways that before were unfeasible. So, the fact that you're building serverless applications already gives you super agility to even do more.
Absolutely. One of the things, we always kind of talk about in this section is, and Paras had already mentioned this, like, hey, got this Lambda, it's going to RDS. and it's just constantly creating more and more connections. And that's the beauty of Lambda, is that it's really, really fast. The downside to it is that it's really, really fast, and it can overwhelm the downstream services. And so typically, throwing in a proxy, or specifically RDS proxy, in between Lambda and RDS is a really good idea. And that's just primarily for connection management and ensuring that you're not overwhelming the downstream system. It's a relatively inexpensive solution to not have to worry about the fact that you're going to run out of connections, because that's another another challenge that we hear a lot of customers talk about when we get into performance and at scale. They get to a certain scale and it stops working. Things start to fail. And then lastly, the other thing we typically, we've gone through everything from the ability to cache and return data quickly, be able to write it out. We really want to talk to you about, how we, what are some other services that we've come up with over time. And during reInvent last year, Lambda Managed Instances came out. And this is kind of a new solution where you can continue to have your existing pipeline. You're writing Lambda from a functional standpoint. You're still able to contain things in microservices, but the difference is now you're taking that Lambda code and you're executing it on EC2 instances that you choose, but AWS is managing for you. And the benefit here is kind of twofold. One, your Lambdas are always running, so there's no cold start. But the other thing is that now if you have an application that is going to have a lot of invocations and is just going to be consistently running, you now have the ability to have that on compute, and you can see some significant cost savings. So this is just another way that we're trying to meet developers where they are, and it's an exciting new feature.
Yeah, that is interesting. No, I love the whole sort of concept of Lambda managed instances. And the funny thing is, Lambda managed instances, as Matt perfectly said, you bring your own EC2 instances, but AWS manages them. You can't SSH into them. You see them in your account. We patch them. We do all that kind of thing for you. And as Daniel earlier said, these can get pretty beefy. So, normal Lambda can get up to 10 gig of RAM, which is proportionally 6 virtual CPUs. Lambda managed instances up to 32 gig of RAM and 16 virtual CPUs. Holy moly, that's a big Lambda function. But yeah, operationally, it's really kind of simple. And I hate to use the term, but I do sort of like the dig when it's partly bringing servers back to serverless. But you don't have to manage them. And so, yeah. But my original point was, if you are concerned about choosing Lambda because you worry about the cost at scale, or you worry about the performance profile and worry about having to make that trade-off sometime in the future, even if it never happens, and so I think I should really be using EC2 or maybe Fargate or this kind of thing, this is also your logical expansion, even if you don't need it in the future. That maybe sound maybe a weird thing to say, but we've spoken to many customers who also choose not to use Lambda because they think there'll be a huge, big cost penalty when they get to scale. And so, but they don't know yet. And so they make these suboptimal architectural choices based on a future what if. And this Lambda managed instances is also a great hedging bet if that doesn't happen. So that may sound like a weird thing to say from me, but it's a useful thing. You want to be a good architect. You want to make future choices. You want to be future proof. And Lambda managed instances is one of those great future-proof options. And it is also technically awesome that we can just manage these EC2 instances in your account, sort out some networking, manage and patch them, spin up some containers, spin them down. Lambda does stuff for you.
Absolutely.
Well,
should we? Oh, go ahead, Paras. What?
Shall we talk about tools?
Yeah, I was actually just going to say.
Two questions that have come in. Darryl Ruggles, welcome back, Darryl Ruggles. Nice to see you again. We'll have to have a future session on optimizations with Lambda managed instances, playing around with these a lot lately. Great idea. We'll put that in the to-do list. And then stay in the pursuit. 8427. Is this with provision concurrency on? And I'm presuming you're talking about Lambda managed instances. Yes, but it's not provision concurrency. It's just by default. When you when you create a Lambda managed instances, you create what's called a capacity provider. It is just some compute capacity. It's a virtual thing. Nothing exists. When you then deploy a Lambda function, it goes, I need to go and deploy some Lambda functions. It goes and deploys some EC2 instances. It goes and actually deploys some containers on those EC2 instances, runs your initialization process, and then waits for your invokes. So it's not called provision concurrency. It's not costed in the same way, but it's basically doing the same thing. And in a way, it's got a sort of similar profile because you're giving it a number, or you can work out the number of invocations you can possibly need, and then we'll scale that up slowly on the back end. So it's not provision concurrency, but think of it as no cold starts in the same way.
And the use case is similar. If you have predictable patterns and you don't want cold start, then Lambda LMI is the way to go. Let's quickly touch upon tools, because I don't want to leave this talk without talking about at least two of the important tools. I have 4 to talk about. We'll see if I can get to the last 2. So tools, why they are important. So there are a lot of things we talked about in terms of how to tune the performance, and a lot of things you don't have to do it yourself. We have some tools to help you do that. Earlier in the talk, we talked about power tuning. So as you can see on the graph, it is intuitive that more memory you give to Lambda function, more CPU you will get and faster it gets. But Lambda cost, or the cost of Lambda, is the function of memory and time. So it costs you money if you give more memory. Having said that, as you add more memory, it becomes faster. So if you see on the graph, the red line on the graph is the latency. As you're giving more memory, it is getting faster. But the blue line is the cost. As you're giving more memory, it is costing you more memory per second, but it's taking less number of seconds or milliseconds or what have you. So there's a sweet spot somewhere in between, and you have a tool to figure it out. It is called AWS Power Tuning. It is an open source tool, basically based on step functions, state machine, and it takes your function and you can run it in the balance mode or performance or speed mode or cost mode, and it will give you the right amount of memory you have to give to your Lambda function to tune it. You can also run it iteratively on Graviton instances and x86 and compare. There's a compare functionality. You can compare those 2 functions on 2 different architectures. So it's a cool tool. It has a lot more functionality. What I'm talking about, there are some documentation you can see or check out those functionalities. Another tool I want to talk about is a Lambda Power tool. So we talked about instrumenting your code and monitoring and all. So there's a code saying you can't manage what you can't measure. So you have to have some kind of techniques and technologies to help you measure the performance, and that's where the Power tool comes into picture. It includes the SDK and the libraries to help you provide the utilities, which are the opinionated best practices utility. It is available in Python, TypeScript, Java, and .NET. And what it gives you is the way to log, trace, emit metrics, implement things like idempotency. It can do the parameters utility with caching and all those goodness we talked about. So you don't have to write the boilerplate code on your own Lambda. You can just use these utilities to implement those methods. Before I move on to compute optimizers and Lambda insights, anything you want to add, Julian and Matt here?
Just 2 seconds. You've still got AWS Power Tuning on the slide. Power Tools. Did you have another slide for that, or are we just talking about Power Tools because that's a separate thing? Just
we were just. I probably Cool. I don't have another slide for that. Sorry.
No, perfect. Yeah, and just because GoBase had said is the x-axis allocated RAM. Yes. So yes. You tell Power Tuning what is the different RAM options, and off it'll go and work it out. And this is actually great for Graviton. How this is Lambda. Yes. Go by side, that's the kind of thing where I picked up different tooling. AWS Power Tools available. It's an SDK, I suppose. Not quite an SDK. It's an addition to your Lambda functions for code, for telemetry and secrets and loads of cool stuff. There's actually no reason not to use it. Well, there may be, but you really should be using Power Tools.
Absolutely, yeah. Specifically, if you are, looking at having, to write boilerplate code like idempotency, like there's just libraries that are already built for you. You don't have to think about it. It just kind of happens. It's pretty great.
Okay. Last two tools I want to quickly touch upon are Compute Optimizer and Lambda Insights. So Compute Optimizer is you use power tuning to figure out what would be the right memory to allocate based on some tests it does for you. But how do you know that it is actually right? So Compute Optimizer uses machine learning to check your data or metrics over the last 14 days, CloudWatch metrics, and it basically figures out whether you are under provision, over provision, or you are, the memory setting is just right. So take a look at that. And last, the Lambda Insights, which is another Lambda layer you can use with CloudWatch. It uses a CloudWatch Insights extension to provide extra monitoring metrics to troubleshoot any problems you might be having in the Lambda. So these are some of the tools I noted down to talk to you about. Anything you want to add, Matt?
That's good. I think the next thing, and typically, we always talk about the idea here is, these sessions are awesome, but there's also great ways that you can learn as well online. A lot of our resources that we talk about are available on serverless learning. There is a lot of learn at your own pace training, and there's also a lot of ramp-up guides. We have Serverless Land as well, and you can, this is actually a link to that. And then lastly, if you have ever thought about, getting a badge or kind of demonstrating your capabilities and knowledge around both serverless and events and workflows, what's great about this is that a lot of the concepts we've talked about are all into this training and also into the exam that you get to take to be able to earn one of these badges. So it's kind of fun, challenge a friend, and be able to show off your serverless smarts, so to speak.
Cool, excellent.
Go ahead.
No, it's fine. Anything else from you two? Well, I was just going to do a question each for you, so we have 2 minutes. Paras, first over to you. What do people that you talk to, developers, customers, what do they get wrong the most in terms of thinking about Lambda performance, or what's the most misunderstood thing that you can be their takeaway today to go and do some research on?
Yeah. So a lot of customers have preconceived notions and they dread about cold start a lot. And then there's a lot of myths or misconceptions around cold start. It does not happen that often as it is dreaded about in the community. It happens, I think it is like the number is less than 1% of our invocations are cold start, and that are also not bad. Cold start developers expect experience in the development environment, but when your code is in production, it's not that bad. So yeah, a lot of misconceptions around the language and the cold start, and it's there are documentations and resources around that.
Cool, excellent. Matt, anything from you to add, or any other anecdotes or things that people need the most help with?
Yeah, no, I think that the biggest thing around, developing at scale is just really thinking through your patterns, thinking through how do you start to plan. So as you get that more complicated diagram where you've got multiple databases and all sorts of microservices, and you're trying to figure out how you're going to handle that, just leveraging the tools like power tuning and power tools can help you not only plan, but kind of look at what's going to happen when things get to scale and you have to instrument your code and figure out what has gone wrong. So, we're super excited.
Excellent. Well, thank you everybody for joining us. Thanks so much for Matt and Paras. If you look on YouTube, in the show notes, there are their LinkedIn profiles and some of the links from the stream as well. And yeah, thanks Matt, thanks Paras for coming on Serverless Office Hours. It's always a pleasure to hear from the gurus, especially with Lambda performance, which is fantastic. And for the people who are joining us, thanks so much. Glad it was helpful for Stay in the Pursuit, and also Victor. We appreciate all of the comments and questions. And to producer Jeffrey, thanks for making things run all perfectly smoothly behind the scenes. Goodbye, everybody. I will see you same time, same place next week for more awesome Serverless Office Hours. Bye-bye.
Thank you. Bye.